Hello everyone, I welcome you all to Physics Wala, and in this session we are going to discuss a very interesting portion of organic chemistry which is actually known as a GOC, that is General Organic Chemistry. And this particular session is going to be very interesting related to the entire application parts related to GOC. Now, if I talk about the organic type of reactions, before understanding the reaction mechanism, before understanding the basic part related to our chapter, which is hydrocarbon, it's very important to understand what is the basic moiety which is used in the organic reaction, what is the nature of that particular part, and what type of electronic effects actually works on that type of species. So that part actually corresponds to the GOC, which is General Organic Chemistry. Now let me tell you what we are going to discuss in the upcoming sessions also. So basically GOC comprises of all the electronic effects which are actually applying on a particular organic compound. In that case, there are different type of electronic effects, starting with the inductive effect, then we have resonance or mesomeric effect, then we have electromeric effect as well as hyperconjugation. So the entire part will be covered in this session, which is GOC. Definitely there are 3 lectures of GOC. In first portion we are going to discuss about the basics related to GOC, then we are going to start with the electronic effects part. Okay, now if I talk about mainly specific this session, we are going to discuss about the introduction part related to GOC, then we are going to discuss a very interesting portion related to the reaction mechanism part, what is the bond cleavage in every type of organic reactions. Then we are going to discuss a specific basic portion, only the introduction portion of reaction intermediates, because after completing the electronic effects we are again going to discuss about the reaction intermediate part and how the applications are going to work, and last part is the starting point of your electronic effects. Okay, so let's start. If I talk about any type of reactions, in case of organic chemistry, definitely organic chemistry is very vast and there are different type of reactions related to organic compounds. So just like any type of reaction, in this case also these reactions are similar to inorganic chemistry reactions. So if I talk about this entire part, we have a particular reactant. This is going to be converted into the product, a very simple type of chemical reaction. Now in case of organic chemistry, this reactant is definitely going to be the organic compound. This is going to be the organic compound, and this product which is eventually going to form after the application of different type of species, that part is basically again the organic compound. Now basically in this case of organic type reactions, we generally use different type of species. So the species used to convert reactant into product, these are known as reagents. That's why in case of organic chemistry, the main use is of reagent, because with the help of reagents we are going to convert different type of organic compounds which are reactant species, initial compounds, and they are going to be converted into final species which are your product part. It can be, these reagents can be anything, it depends upon the type of reaction which we are using or which we use for the conversion part. So this reagent chemistry is actually very vast in case of organic chemistry. We have different type of reagents, starting with acids, then bases, then different type of species which brought change in the entire reaction or which converts reactant into product. These species are basically your reagents. Now in case of these type of reactions which are mainly organic reactions, we need to understand what is bond cleavage. We need to understand what is bond cleavage. Bond cleavage is nothing but a simple analysis of bond breaking. It is nothing but bond breaking, because the basic meaning of organic type of reaction is breaking of bonds of reactant and eventually formation of new bonds into the product. The simple process is bond breaking in reactant, and next part is new bond formation in product. That is the simplest idea about the reactions. Now let's say I have a species which is A is connected with B. In this type of species, mainly always remember, whenever we talk about organic chemistry or organic compounds, whenever we talk about organic compounds, the main type of bond is basically your covalent bond. The main type of bond is basically your covalent bond. Covalent bond is that type of bond which is formed by the equal sharing of electrons generally. Okay, so this is the first situation. Let's say there is a bond between A and B, and I am going to break that particular bond. That breaking comes under the category of bond cleavage. I hope this part is clear. This is the basic idea related to the entire part. Okay, I hope each and every term is now clear to everyone. Now, what about the bond cleavage, bond breaking, and what type of species are going to be formed after the bond cleavage? That part is very important. So, if I talk about the first part, in case of bond cleavage, always remember it can be first type, which is homolytic cleavage. It can be homolytic cleavage. Homolytic cleavage means it's a very simple thing. Let's say I'm starting with a species which is A and B, and I'm breaking that particular bond. I know there is only one bond which is present, so both contributed one electron each. After the bond breaking, each species actually gets individual electrons equally. Okay, so after the bond formation, it will become A with odd electron as well as B with odd electron. So you can simply say, in case of homolytic cleavage, after bond breaking, each species gets its own electron and form odd electron species, and eventually form odd electron species. Because during the formation of a covalent bond, if there is only one single covalent bond, it means one electron from each species is going to participate in the bond formation. Now in the bond breaking also, if both the species gets one electron each or their original electrons, then definitely that type of cleavage is basically homolytic cleavage. I hope this part is clear. Now these species are basically odd electron species. These species are basically your odd electron species. In case of carbon, because most of the organic compound comprises of carbon only, we generally say that they are going to form an intermediate. Intermediate formation takes place. What is an intermediate? Intermediate is the type of species which is going to be originating in the reaction, but finally it is not present in the final product. Definitely it's going to be appearing in any step of the reaction after the bond breaking, but it's not going to be present in the final step. Okay, that type of species is intermediate, and this intermediate is actually known as free radical. This entire part will be known as free radical. I hope this entire part is clear. So let's say I'm taking the example, we have carbon as well as carbon bond. Just like that, if I'm breaking that particular part by homolytic cleavage, I can say both the species are going to form this type of moiety. Okay, and both the moieties are basically your free radicals. I hope this entire part is clear. Now the basic idea, like what drives the homolytic cleavage. So always remember, there is one condition. Just note down this important condition. When the difference of electronegativity between two atoms is very less or close to zero, in that case only free radicals are going to be formed. In that case, free radicals are going to be formed. Just note down these important points. Okay. I hope this part is clear. I hope this part is clear. This is the first point, that the electronegativity difference should be very, very less between two atoms. Then only you can form free radicals in a particular species. In the same way, if I talk about the next point, this type of intermediate formation, generally takes place in gaseous state or in non-polar solvents. I hope this entire part is clear. I hope this part is clear. This is the second point related to the homolytic cleavage or the formation of free radicals. In the same way, if I talk about the next part, second part is heterolytic cleavage. Second part is actually known as your heterolytic cleavage. Now, what happens in case of heterolytic cleavage? Again, in this particular case, we have A and B which are connected with the covalent bond. Now, this cleavage actually takes place in such a way that one species gets both the electrons, and another species will not get any of the bonded electrons. This type of a cleavage is actually known as heterolytic cleavage. So, bond breaking takes place in such a way that one species gets both the shared electrons and another species will lose all the shared electrons, or I can say not all the shared electrons, lose both the shared electrons, because we are considering single bond in this particular case. Okay, that type of analysis or that type of bond breaking is actually known as your heterolytic cleavage. Now, in case of carbon, let's say we have this carbon carbon bond, we have this carbon carbon bond, and this bond is going to break heterolytically. It means two electrons are there, so one species is going to get both the two electrons. So in this particular case, you can say that one species is going to get both the electrons, so definitely one extra negative charge is going to appear, and that species is going to lose all the electrons, so it's going to get positive charge. Okay, now this species, which is positive charge species forming after the heterolytic cleavage, is generally known as carbocation. This species is known as carbocation, and this species is known as carbanion. this species is known as carbanion. I hope this entire part is clear. I hope this entire part is clear. Just note down these important points. Okay. Now the next part is very interesting. This type of cleavage occurs due to large difference of electronegativity between the atoms. So this actually arises just because of the presence of large electronegativity difference between the atoms. Okay, then only this type of cleavage is going to occur. For example, when carbon is attached to highly electronegative atom, when carbon is attached to highly electronegative atom, and somehow this bond breaking is going to take place, and definitely this carbon is eventually going to get positive and this electronegative atom is going to get negative charge. So in this case, carbocation is going to form. It may be possible when the carbon is actually attached to electropositive atom, when it is attached to electropositive atom, and then bond breaking is going to take place. In this particular case, you can see there will be a formation of carbanion takes place. So we know, if I talk about the reaction intermediates, if I talk about the reaction intermediates, we have three type of intermediates mainly. First one is known as free radical. First one is the free radical or odd electron species. Second one is carbocation, and third one is known as carbanion. Now, main thing in this particular case, always remember these two species. These are electron deficient species. They actually require electron to get the stability. But this species carbanion is electron rich species. This species is electron rich species. So there is a difference between these two type of species, and that's why the electronic effects are very helpful to understand the stability of these type of reaction intermediates. If a particular process is going via the formation of a reaction intermediate, then we need to make sure that whatever reaction intermediates are there, they should be stable. If they are not stable, definitely the reaction is not going to go via the formation of any type of reaction intermediate. So it's very important to understand the stability of reaction intermediate. That's why we have different type of electronic effects. I hope up to that part everything is clear to everyone. Just note down each and every point, because these are very important points to understand the basic nature of all type of reaction intermediates as well as all type of electronic effects. Okay. I hope up to that part everything is clear to everyone. Now it's time to discuss about the reaction intermediate part. What are the reaction intermediates? So generally, the reaction intermediates are much more clear after understanding the basic idea of electronic effects. So let's start first the discussion of electronic effects, then we will move on to the stability part of reaction intermediate. Just remember one thing, that these two species are basically electron deficient because they have less electrons in their octet, but this species is actually electron rich in nature. So their stability is going to differ in terms of electronic effects. Okay, so if I talk about the electronic displacement effects, in that case the effect which appears due to the electronic distribution, just because of the electronic distribution in the organic compound between carbon atoms or any type of other atoms which is involved in the organic compound, that displacement part or electronic distribution part actually arises different type of effects. These are actually known as your electronic displacement effects. I hope this part is clear. I hope this part is clear. Now, if I want to categorize these electronic effects, I can say that we have two simple classifications. First effect, which is already or permanently present in the organic compound, and second effect, which may arise due to the presence of a different type of species or different type of reagents in the organic compound. So the first type, which is basically known as the permanent effect. In the case of permanent effect, you have inductive, mesomeric, as well as hyperconjugation effect. These are actually known as your permanent effects. Okay, they are going to be there from the initial stage when the organic compound is already present. There are certain effects which are actually known as temporary effects, and the main part in case of temporary effect is basically your electromeric effect. There is one more part which is inductometric effect, but mainly we are going to be focused on the electromeric effect part. I hope this simple classification is clear. Now it's very easy, or I can say very important to understand what is inductive, mesomeric, as well as hyperconjugation effect first of all. Okay, then we are going to proceed for the next part, what is the basic nature of each and every type of effect. So I'm starting with the permanent effects, which are definitely going to be present in organic compound from the initial position. Okay, so permanent effects are basically present in organic compound due to the presence of different atoms or bond distribution. Okay, so they are not going to be affected by the presence of any type of reagent, but temporary effects only arises when a specific reagent is coming near the organic compound. These arises due to the presence of reagent. So if the reagent is not present, then definitely these temporary effects are not going to work. I hope this part is clear. I hope this basic idea is clear. Just note down this classification. Then we will start with the first part, which is inductive effect. Okay. Now, if I talk about the inductive effect, which is also known as I effect, if I talk about the inductive effect, which is also known as I effect, always remember this type of effect only works when the carbon atom is attached to any type of other atom where there is a difference in their electronegativity. So basically, when a sigma covalent bond is formed between two atoms of different electronegativity, then the sigma bond pair electrons are shifted towards more electronegative atom, and due to this shifting of electron, dipole is created between two atoms. It's a very well known phenomena, you all know from your chemical bonding part. Let's say I have this species which is A as well as B, and let's say in first case electronegativity of A is actually more than electronegativity of B. Let's say this is the first case. Then you know that all the electron density will be much closer towards A, and it will get partial negative charge, it will get partial positive charge, and that is the basic creation of a dipole. It may also be possible that electronegativity of A is less than electronegativity of B. In that case, the situation is entirely different. So all the electron cloud will be much closer towards B, and it will get partial negative charge and it will get partial positive charge. So this is the creation of dipole. So dipole will be created in both the cases. Dipole will be created in both the cases. So I hope the basic origin of this entire part is clear to everyone. Basic origin is clear to everyone. I hope the basic origin is clear to everyone about the inductive effect. Very easy. So always remember, this always arises due to different electronegativity atoms in the sigma bond. Okay, and what is the consequence? Due to this shifting of electrons, we can say dipole is created between two atoms. So this is the important part. Always remember, in case of inductive effect, only the shifting of electron cloud is occurring via sigma bond. Via sigma bond. Just note down that important point. Okay. I hope this entire part is clear. Okay. Now, what about the next part? After the creation of dipole, the sigma bond electrons in the chain are also shifted, because it will, the dipole which is created on one end, it's going to be localized on different type of other atoms also. But definitely that is distance dependent. It's not going to occur after 3 or 4 carbon atoms. So we can say due to this dipole, the sigma bond electrons in the chain also shifted, and the chain becomes polarized, and this effect of polarization in the chain due to dipole is actually known as inductive effect. So this is the most important part related to your inductive effect. For example, that let's say I have a carbon, 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 and now we have electronegative atom. Let's say so first of all, this electronegative atom is going to attract all the electron cloud toward itself. So definitely in this particular case, a partial negative is going to appear on the electronegative atom, and partial positive will be appearing on the carbon. Now this carbon induces its effect on the next carbon, and again it will become partial positive, although this creation of dipole is less in the second carbon, and eventually it will create partial positive, which is a very less. Okay, so maximum separation is occurring on this side, then this side, then this side, and after 3 carbon you cannot see any other effect. Okay, you cannot see any other effect, but you can see the electrons are going to move towards the electronegative atom, and this entire shifting is occurring on the sigma bond. So that part corresponds to inductive effect. I hope this entire portion is clear. Just note down this definition. It's a very important part. This is one of the example. It may be like reverse also, that we have electropositive atom, and then it's going to shift the electron density towards carbon atom. It's also possible. So that part also we are going to discuss. Okay. Now, this effect is transmitted through the chain of sigma bonds and diminishes with increasing chain length. And one can see this effect working up to 3 carbon atoms in the chain. From this particular part, we can simply say that this effect is distance dependent. We can simply say that this effect is definitely going to be distance dependent. I hope this entire part is clear. I hope this entire part is clear. I hope this part is clear. Very interesting observation from the inductive effect. Now, is there any other type of inductive effect? Like, what is the classification of inductive effect? That part is also very important. So there are two types. First of all, if electronegative atom is attached, which can attract all the electron cloud towards itself, it may be possible that another type of group is present which can donate the electron density towards carbon atoms in the organic compound via sigma bond. So definitely there are two type of effects. First one is known as a plus I effect, and next one is known as minus I effect. Okay, so let's start with the classification, but before that, let's talk about certain basic features related to the inductive effect. First part in this case, that inductive effect is a permanent effect, because the atoms are actually attached to the carbon atom. It is independent independent of the presence of any reagent. It is originally present in the organic compound itself. That's why it's a permanent effect. Let's say one reagent is approaching towards the organic compound. So this reagent approach is not going to hamper anything. It is already present in the organic compound just because of the presence of two different electronegativity atoms. So that part is basically permanent effect. I effect is a distance dependent and negligible after 3 carbon atoms in the chain. That part we already know. That it's a distance dependent thing, and after 3 carbon atoms you will not see this type of effect emerging in the entire organic compound. I hope this part is clear. I hope this part is clear. Okay. Now the next part is inductive effect is operative only through sigma bond, but it's not going to affect pi bond at all. So this type of effect has no meaning with a pi bond. It's not going to interfere with the pi bond formation. It only works in the sigma bond. I hope this part is clear. I hope this part is clear. Now, what about the actual bond? Because originally in the hydrocarbon, we have a CH bond. So, in case of a CH bond, it is considered as the electronegativity difference between carbon and hydrogen is a very less. So, the inductive effect in case of CH bond is actually taken as a 0, as a standard. So, the CH bond is the reference of inductive effect, that is the electron movement or polarity in the CH bond is considered to be negligible, and then I effect of hydrogen is actually taken as 0. A very important point. A very important point. Because I need to see what type of groups are involved, so I need to understand what is the standard in that case. So CH bond is taken as a standard because the electronegativity difference between these two parts is actually close to 0. So there is no charge separation, and the inductive effect of hydrogen is always considered as 0. I hope this part is clear. Just note down these points. Okay. Okay. Now, on the basis of electron releasing power, which can donate the electrons via sigma bond, or electron withdrawing power, which can withdraw the electrons, more electronegative atom, we have two types. First one is actually known as the plus I effect, and next one is actually known as minus I effect. So these are the two special type of effects occurring in case of organic compounds when the electronegative atom is attached or any type of a species which can donate the electrons. So plus I means, simply you can understand plus I as well as minus I meaning. Plus I means we are talking about the electron releasing groups. We are talking about the electron releasing groups. Electron releasing groups, and this effect is basically due to electron withdrawing groups. Electron withdrawing groups. Okay, I hope this part is clear. So if any type of electron withdrawing group is actually attached to carbon in the organic compound, definitely you can see minus I effect, and if any species which can donate the electron is attached to that particular part, you can see electron releasing groups or plus I effect. I hope this part is clear. Now, how to understand this entire part? It's very easy. It's very easy. If I talk about the minus I effect, I can say the group which withdraws electron cloud is known as minus I group, and its effect will be minus I effect. For example, again the same type of analysis, we have this carbon-carbon arrangement, and generally we have electronegative atom attached. Generally. So definitely electronegative atom is going to attain partial negative, it will be partial positive, it will be partial positive, it will be partial positive. But you can see that electron density is going to move towards this electronegative atom. That transfer actually withdraws the electron density from the carbon atoms. So definitely that corresponds to minus I effect. I hope this part is clear. Now, what are the groups or what are the species which are involved? How can we see that this type of effect is going to work, sir, in that species only? So, there is a list of species. There is increasing order or I can say decreasing order according to their strength by which they can withdraw the electrons. Okay. So, there is a specific list. You have Nr3 positive, Sr2 positive, NH3 positive. So positive charge means these species are already having positive charge. Definitely they are going to withdraw the electron very, very fast. Then we have NO2. NO2 is a very interesting species. NO2 can withdraw electron because nitrogen is electronegative and it is attached to oxygen. So nitrogen, so we have one oxygen like this, and this species is there. So definitely both the oxygens are electronegative. They are going to withdraw the electron density from nitrogen, and nitrogen eventually withdraws the electron density from carbon. So definitely this effect is very much prominent in case of NO2. We have SO3H, we have CN group, we have CHO, which is aldehyde group, we have carboxylic acid group, we have a fluorine, chlorine, bromine, iodine, OR, OH, NH2, triple bond, we have benzyl part, we have double bond, and then hydrogen, which is always considered as 0. I hope this part is clear. Always remember this table. It's a very interesting table. You can find this table in NCERT as well as any other book which you already have related to organic chemistry. Okay. In the same way, if I talk about the plus I effect, it is exactly opposite to minus I effect. And we can say this group which donates or gives electron via sigma bond only, is known as plus I group, and this effect is actually known as plus I effect. This effect is known as plus I effect. So let's say there is one species, we have carbon, 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 and let's say we have one species which is electropositive. We have one species which is electropositive. Let's say. So definitely this electropositive species is going to give electron, and this will get partial negative, this will get partial negative, and this will get partial negative. So definitely this type of movement of electrons is basically corresponds to plus I effect. Now what are the species which are involved? So generally all the alkyl groups, they are very good donor atoms. So in that case, always remember all the alkyl groups. We have O negative, we have NH negative, we have a C double bond O negative. These species are basically electron donating in nature, and generally negative charge atoms or groups, they are very good donor species. So always remember this type of effect will be working as plus I effect. I hope this entire part is clear. Now the thing is, if they are working on a particular atom, so let's say we have a carbon which is attached to this oxygen negative. Oxygen negative is already electron rich in nature. So definitely in that case, it's going to give the electron density towards the carbon atom, whatever is involved. So always remember, on all the alkyl groups, if I talk about the alkyl groups, you have, let's say we have a carbon, 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 and it is attached to CH3, one methyl group. Definitely it's going to give its plus I effect. It may be possible that we have one carbon which is attached to CH3 as well as CH3. So definitely both the parts are going to involve. And let's say in third case we have carbon which is connected to CH3, CH3, CH3. Definitely these three parts are going to give electron density towards the carbon atom. So this is the basic idea about the plus I effect. But the main question is, sir, how can we understand like in which species they are going to be applicable? What type of questions can be asked? What is the nature of their application? How can we apply these type of effects? So let's try to decode that part. In case of, if I talk about the plus I order, so just like the table which is present in the minus I order, so this particular part corresponds to the same thing. You have a CH2 negative, NH negative, O negative, COO negative, tertiary alkyl groups, secondary alkyl groups, primary alkyl groups, then methyl group, and then hydrogen. I hope this entire part is clear. Just remember that you can find this type of table in any of the book, okay. Maybe some values are missing, maybe some species are not there. You can find that entire part in any of the corresponding book, okay. Now the next part is Next part is order of a plus I effect depending upon the number of carbon atoms. So always remember, as the number of carbon atoms are increasing in the donor species, definitely its donating power is going to increase. So let's say we have CH3CH2, we have CH3CH2CH2, we have CH3CH2CH2CH2. So one group is this, next group is this, next group is this. Always remember, as the number of carbon atoms are increasing, their plus I power is going to increase. Their plus I power is going to increase. So in same type of donor atom, because every time we have alkyl group, every group in this particular case, I am considering these groups are alkyl groups. So if somebody asks you, in alkyl group, if number of carbon atoms are increasing, their plus I power is going to increase or decrease. So definitely their plus I power is going to increase in those species. I hope this part is clear. So we can say plus I is directly proportional to number of carbon atoms in the same type of alkyl group. In the same type of alkyl group. A very important analysis. A very important analysis. Just note down this point. Just note down this point. Okay. In the same way, if I talk about the application part of inductive effect, you can see n number of applications in case of organic chemistry. It can definitely affect the acidity, it can affect the acidity as well as the basicity of organic compounds, whether the organic compound will be a good acid or it's a good base. It depends, it actually affects the dipole moment, because just because of the difference between the electronegativity, partial charges are going to create, and definitely that is the origin part of dipole moment. It talks about the stability of reaction intermediates, and this is the most important part. This is the most important portion, because it decides the type of reaction mechanism by which reactant is going to be converted into product. Okay, and it also hampers the reactivity of compounds in the chemical reaction, which is a consequence of this entire part. Okay, so let's try to figure out what is going to happen when we talk about the applications related to inductive effect. Now in that case, in deciding the acidic strength of carboxylic acid, deciding the acidic strength of carboxylic acid. So let's say we have a particular acid which is R C double bond O OH. We know that this is the carboxylic acid, but its acidic strength means that it's going to eventually lose H positive and it's going to form RC double bond O negative. By anyhow, if this part, so this is the acid, so definitely after the loss of one H positive, that will be the conjugate base, Now your task is to understand whether this conjugate base is stable or not. So the main task is to know about the stability of conjugate base. There are two conditions. If this conjugate base is highly stable, if this conjugate base is highly stable, then you can say that acidic strength is going to be high. It's going to be a way much better acid. It may be possible that it is highly unstable. If it is highly unstable, then definitely it doesn't want to convert from acid to this conjugate base, because this is highly unstable. In that case, the acidic strength is going to be very, very low. I hope this part is clear. Just note down this important point. Then we will understand what is going to happen in this particular case. Okay. Now one thing which I want to mention here, as you can see that this conjugate base is negatively charged in nature. This conjugate base is actually negatively charged in nature. So you can say, one thing you can say for sure in this particular case, that I have to stabilize the negative charge. If negative charge is stable, then definitely entire part will be stable. So one thing, if I want to talk about the stability of negative charge, always remember all the electron withdrawing species or electron withdrawing groups increases the stability. Negative charge will be stable if all the negative charge is going to be distributed equally in the atom. So if any electron withdrawing group is present, definitely negative charge will be stabilized. If I talk about the same part for positive charge, so positive charge is electron deficient, so it needs the species which can donate the electrons so that it can become stable. So in that case, always remember that electron donating groups increases its stability. I hope this part is clear. So eventually we know that conjugate base is a negatively charged species. So all the species which can lower down its negative charge or which can distribute the negative charge equally in the entire species, they can increase the stability. So that's why this minus I effect is always increases the acidic strength. Always remember a very interesting observation, that minus I effect or minus I groups are going to increase the acidic strength in the particular carboxylic acid. In the same way, this plus I effect is definitely going to increase the basic strength, because plus I means they are going to increase the electron density so that base becomes a very good species which can donate the electron pairs. Okay, so that is the basic idea related to the acidic as well as basic strength. Okay, I hope up to that part everything is clear to everyone. Now we are going to discuss about this species, like what is the basic idea of basic strength also, just like the same analysis, Okay, so if I talk about the basic strength, first of all you need to understand the meaning of basic strength. Here the meaning of a basic strength is tendency to donate lone pair of electrons easily. Okay, this is the basic tendency of a basic strength. Because basic strength always arises in all those species which contains lone pair of electrons. Generally we have like this type of species. Let's say we have RNH2, so it has lone pair. If this lone pair is available for the donation, tendency to donate the lone pair of electrons, or you can say availability of lone pair for donation, it should be there. Okay, it should be there. So how can I increase this donating power? If I can somehow manage to give it this particular atom more electron density, so this lone pair will be easy to donate. That corresponds to your species which is having a good basic strength. So always remember groups which can increase electron density on donor atom makes it easy to donate its lone pair. And hence you can say that basic strength is going to increase. Okay, that's why we have included that plus I effect is going to increase the basic strength. I hope now this entire part is clear. Just note down these two important points. Now let's talk about certain examples. how can we visualize that acidic strength or basic strength is going to increase or decrease? This is the most important part. Okay, so I'm starting with the first example. In this particular case, you can see we have the first atom, carboxylic acid, second carboxylic acid, third carboxylic acid, and fourth carboxylic acid. The main difference in each and every part is basically the position of this Cl. The Cl is present on the first carbon here after COH. This is present on the second carbon. This is present on the third carbon. And in last species, there is no any type of species. Now this chlorine, we know that chlorine is a nothing but it is minus I, or you can say electron withdrawing species or group. It's going to show minus I effect. It's going to show minus I effect, but we know that this minus I effect is distance dependent. So if it is present on the first carbon, it will acquire partial positive, and after the release of H positive part, the negative charge will be highly stabilized with this particular part. This is present on this side, so this will be partial positive and partial positive. So less positive charge is present on this carbon, so it's not going to hamper that much. In this particular case, you have partial positive, partial positive, and partial positive. So this carbon has a very less positive charge and there is no positive charge. So you can see that only this partial positive charge is going to withdraw the electron density from the negative charge, and it makes it highly stable. So you can see the stability of a first part will be maximum, then a second part, then third part, and least one is a fourth. So trend is already given to you. Trend is already given to you. I hope this part is clear. I hope this part is clear. Because we know that species is going to form CH3, CH2, then CH2, then CH and Cl, and eventually that will be COO negative. So the main question is stability of conjugate base. The main question is stability of conjugate base. Conjugate base will be stable if any species can withdraw negative charge electron density. So you know that carbon partial positive, partial positive, and partial positive. This has maximum tendency to withdraw. So definitely it will make conjugate base highly stable than this part, and in this case conjugate base is not at all stable, because every group is your basically group which is going to be working as plus I effect. So this is going to show plus I will be there. So conjugate base becomes highly unstable. Negative charge only stabilizes when any species can withdraw its electron density. Okay, if any species is increasing its electron density, then definitely that will be highly unstable. Positive charge will be stabilized when any species can give its electron. If any species can withdraw its electrons, definitely that species is going to be highly unstable. Okay, I hope this part is clear. I hope this question is clear. In the same way, we know that minus I effect increases the acidic strength. Moreover, it is distance based effect. So where the minus I is nearest to COH, it makes acid strong. That is the explanation. If you want, you can note it down, but otherwise we have already explained the entire part. Okay, I have written it because you get the proper notes, like what is the explanation of the entire part. Okay, now let's talk about the next part. For example, we have CH3, sorry, COH, CH2. This should be NO2. Sorry, it's a typo error. It's a typo error. It's going to be NO2. Okay, then we have a COH, CH2F. Then we have a COH, CH2, OCH3. Then we have a COH, CH2, CH3. Now, in this case, we have NO2 group. We have NO2 group. In this case, we have F group. In this case, we have OCH3 group. And last part, we have CH3. Now we generally know that whenever we talk about these two species, definitely we are talking about minus I effect. We are talking about minus I effect. Higher the minus I effect, more will be the stability of conjugate base, which is going to form after the loss of one proton. So definitely acidic strength is going to be very, very high. So you can simply say the correct order is going to be 1, then 2, then 3, and then 4. Because in the case of NO2, since it has maximum minus I strength, NO2 comes far, far away from F. So you can see, I can show you the table if you want. I can show you the table. Okay, you can see this table. So NO2 is present here, but if you talk about the fluorine, fluorine is present here. So definitely NO2 has much more minus I effect in comparison to F. So definitely it can withdraw electron density much more easily in comparison to F. That's why the conjugate base which is going to form in this case will be highly stabilized in comparison to this. Now if I talk about the rest two parts, they are going to show plus I effect, and these plus I effect is going to destabilize the conjugate base. So you can say the correct order will be 1, 2, 3 and 4. I hope this part is clear. Explanation is already given to you, but you know the actual meaning in this particular case. I hope this part is clear. A very interesting analysis related to conjugate base as well as conjugate acid. Okay. Now if I talk about the stability of reaction intermediates, first of all, if I talk about the carbocations, we know that carbocations are positive charge species. These are positive charged species. And I told you, positive charge species are basically electron deficient in nature. They are electron deficient. They are electron deficient in nature. So we need a type of species which can donate the electron density. So always remember, these are stabilized by plus I groups. I hope this part is clear. These are stabilized by plus I groups. Just like that, stability of a free radical is the same. These are odd electron species. These are odd electron species, but these are again electron deficient in nature. And you can say they are going to be stabilized by plus I group again. Now, if I talk about the stability of a carbon ion, I can say carbon ion is negatively charged species. Carbon ion is negatively charged species. It means they are electron rich in nature. They are electron rich in nature. So definitely any species which can withdraw their electron density makes them more stable. So always remember that minus I groups increases stability. I hope this entire part is clear. I hope this entire part is clear. Very easy analysis, very interesting analysis. I hope this part is clear. I hope this part is clear. Okay. Now, if I talk about the stability of alkyl carbocation, we can say carbocations are electron deficient species and they are stabilized by plus I effect and destabilized by minus I effect. Okay. We can take certain examples also. We can take certain examples. So in that case, if I talk about the species, let's say we have a carbon attached to hydrogen and hydrogen and positive charge. This is the basic species, methyl carbocation. Then we have which is CHH and one CH3 is there. Again it is positively charged. You can say we have H. Now we have 2 CH3. Now we have 2 CH3 and this is again positively charged. Okay, so you can say there is no inductive effect. There is inductive effect from one side, there is inductive effect from two sides. Okay, so that part will be highly stable, then this part, and then this part. Okay, I hope this part is clear. Now what about their nomenclature? This cation is known as methyl carbocation. This part is known as methyl carbocation. Now the carbon which is positively charged is connected to one carbon only. It is known as 1 degree carbocation, or known as primary carbocation. Okay, when it is attached to only one carbon atom, the positively charged carbon atom when attached to only one carbon atom. In this case, this carbon atom which is positively charged carbon atom is connected to two other carbon atoms. It will be 2 degree or secondary carbocation. It will be 2 degree or secondary carbocation. There might be a case that this carbon which is connected to three other carbon atoms, this positively charged carbon atom is connected to three other carbon atoms. That will be your 3 degree or tertiary carbocation, is known as 3 degree or tertiary carbocation. Okay, and this is going to be highly stable. Okay, I hope this part is clear. Just note down these points. Okay, now if I talk about the stability of a free radical, same type of thing is there. Stability of free radical is basically directly proportional to the presence of plus I effect and inversely proportional to minus I effect. Same type of thing is there when we talk about this entire portion. Now how can we define? Again, if carbon is present only with hydrogen, then it is methyl free radical. If it is present, if it is connected with one carbon atom, definitely it is primary free radical, then secondary free radical, then tertiary free radical, or you can say 1 degree free radical, 2 degree free radical, 3 degree free radical. And always remember, 3 degree free radicals are highly stable in comparison to 2 degree, which are highly stable in comparison to 1 degree, which is stable in comparison to methyl free radical. Everything is same in this analysis also. Okay, I hope this part is clear. I hope this part is clear. Now what about the stability of carbon ion? It is exactly opposite to carbocation on free radical. In this case, electron withdrawing groups are going to increase the stability and electron releasing group are going to decrease the stability. Means it is directly proportional to the strength of minus I group, but inversely proportional to the strength of plus I group. I hope this part is clear. So it is exactly opposite to the carbocation and free radical. It means 3 degree carbon ion is highly unstable, then 2 degree carbon ion, then 1 degree carbon ion, then methyl carbon ion is highly stable. I hope this part is clear. I hope this part is clear. Because this 3 degree carbon ion, all the CH3 groups are plus I groups. So presence of plus I group makes it highly unstable. So 3 plus I groups are there, highly unstable. No plus I group, highly stable. I hope this entire portion is clear. I hope this entire portion is clear. So we have covered each and every part related to the basic applications of inductive effect as well as basic applications related to reaction mechanism type. What is the basic idea of your homolytic cleavage as well as heterolytic cleavage, why the reaction intermediates are going to be formed, and how plus I and minus I are going to affect the acidic strength, basic strength, your stability of carbocation, carbon ion and free radical. Okay, we are going to discuss some more questions related to the entire part of inductive effect, and next part will be your resonance, or I can say mesomeric effect. That part we are going to discuss in the next session. I hope everyone enjoyed this session, learned something new from this session. Remaining part will be covered in the next session. Okay, so bye bye everyone. Thank you so much.